everybody, welcome to Newtown Creek. My name is Lisa and today we're going to be going through a water quality field activity where we're going to learn how to use some of this really simple equipment. We've got a dissolved oxygen test, which is a color indicator. We are going to be measuring water temperature with our Celsius thermometer. We're going to be measuring salinity with our hydrometer. And we're going to be taking a look at pH using these very simple pH test strips. And last but not least, we'll be measuring turbidity with this fantastic Secchi disc. So the first thing that we're going to do is I'm going to put on my gloves and use our handy dandy 1 gallon bucket to collect some water from Newtown Creek. So before we get started, first thing I need to do is fill out some of this water quality data sheet. So you always have to write your name on everything, the name of the site. This is Kingsland Wildflowers. And our water body is Newtown Creek. Okay, so now that we have our site data written down, we know what tests we're going to do, we're going to start moving into taking these tests. So first thing I do is put on my gloves because Newtown Creek is a super fun site and it does have polluted water and I always want to protect myself. And then I hopefully don't make a giant knot out of my rope, which I have. Okay. This is my 1 gallon bucket and I'm going to just drop down into the water. And it's kind of a little ways down because it is almost low tide. Okay, so I have my sample. First thing we're going to do is put our thermometer in the water so that it can start taking the temperature. And then the first test we're going to do is dissolved oxygen. You want to do this one first because the oxygen in the bucket, in the water in the bucket, will change over time. So again, this is a color change kit. So we're going to look for how the water and the chemicals in this ampule change as it's exposed to the sample that we've got. So very carefully, without disturbing, we're making air bubbles in my little sample here. Break the tip off my ampule. Break the tip off my ampule. And then I'm going to invert it a number of times, and you can see the color changing. So there's a chemical reaction taking place inside this ampule, right? You can see it there. How's that look? So what we want to try and do is match the color in our ampule with the color on this scale. So are we at number 1? We're closer to number 12. And what do you guys think? You can take a minute now to write down your observation. To me, it looks like we're somewhere in between 4 and 5. How's that look to you guys? Okay, so this is going to be our data point number 1 for dissolved oxygen. You can say 4 or 5 or 4.5, or if it looks like something different to you, you can also write that down. Okay, so here we have our second test, which is the temperature test, and hopefully you can read that. But it looks like it's around 22 degrees Celsius. So that's somewhere in the mid-70s. You can look that up on your own. Okay, and so the next test we're going to do is a test for salinity, which is how much salt is in the water. So we will measure that using our hydrometer, which reads the measurement in parts per thousand, which is the same thing as saying milligrams per liter. And so if you know that the ocean is ordinarily around 35 milligrams per liter of salt, and freshwater is 0 milligrams per liter of salt, Newtown Creek is brackish water, which means it's a mix of both. And so this reading right now reads just over 22 parts per thousand, or 22 milligrams per liter. And so it's pretty clear it's a nice mix of salt and fresh water. So our next test is going to be pH. And so that is a logarithmic scale, which goes from 0 to 14. 0 is very acidic and 14 is very basic. And the ocean is usually around 8.2. And that is very important because having a neutral pH or a slightly alkaline pH is really important for fish and shellfish development and our coral reefs and all kinds of stuff like that. And so this is also another color change test. And so what we'll do is we'll look at our test strip. This is without any water on it. We'll compare it to where it matches on our indicator guide. So we'll just put the strip in the water for a little while, and then I'll pull it out, and here we go. So you can see there's already an instant color change, and that'll change for another minute or so. It looks like we are, I don't know, what does that look like to you guys? 6.5, 7, 7.5? I don't think it's quite 7.5, but maybe. Looks to me like it's pretty neutral. And so that is slightly acidic as compared to its natural or normal levels of around 8.2. Okay. So now we'll move on to our last test that we're going to do today, which is using the Secchi disc to measure visibility underneath the water, and that measure is called turbidity. These black and white squares will slowly disappear the deeper into the water it goes, and so we're going to count how many little knots on this rope we pass as it goes down into the water, and we stop counting when the Secchi disc disappears. And so then we'll be able to say there's 2 feet of visibility or 10 feet of visibility, and then we can have a good measure of the visibility and the turbidity in the water. Okay, so here we go. We're going to lower it down. Nice and slow and careful. We have some pretty funky stuff in the water today. It is a new moon and it is low tide, and so all of those factors make a difference in our water quality observations for the day. Okay, so you can see down at the bottom we have a knot about to go underwater, so we've got 1 foot, 2 feet, I can still see it. Bring it away from the side a little bit. We're at 3 feet, and I can still make it out. Oh, but it's quickly disappearing, and I'd say 3.5, 4 feet, and it is totally gone from view. So 3.5, 4 feet of visibility. And since we're here, now is a good time for you to look out at the water and make some other general observations. So what do you see in the water? Are there things floating? Garbage? Is there oil? Is there any sort of machine? And what does it smell like? Those are all really important observations to make when you're taking your water quality data. So you have your observational or qualitative data, and then you have your quantitative data that you're collecting. Both are very important. So that's it. Those are our tests for the day. If you were here as a class, we would do them as groups, and you would do them multiple times because it's important to have data that you can average, that you can replicate every single time. We didn't do all of the water quality tests that are on the water quality data sheet, and those are the nutrients and the fecal coliforms, but you can reference the water quality tests that we've been doing over the last couple of years to get an idea of what those numbers are, whether it's mid-September or mid-May. We have those numbers from April through October every year for the last couple of years. So check out these, they'll help inform your next activity. Okay, thanks so much.